Alright, in this episode, we are going to go through the intro to log analysis room that is inside of the log analysis module for the SOC Level 2 pathway of TryHackMe. This is going to be officially episode 3, and it's going to be the very last room inside of log analysis before we actually jump into advanced Splunk and advanced Elk and all the good stuff that comes with SOC Level 2. So let's jump into the intro real quick, and then we'll jump into the contents of the room. Alright, the first thing that I want to tell you is this is actually a free room that's available on TryHackMe for everybody with a free account. You don't even need to pay for it or anything like that, even though it's super affordable. But you can use the link in the description below, get yourself a free membership, and even if you want, you'll get a discount on the paid membership. And yeah, you could do everything inside of this room for free. And I think there's actually going to be certain there's going to be task files and things like that, so that means we can definitely use the attack box, which I'm going to start right now just to get ahead of the game. And then yeah, that's pretty much it. So I do recommend, if you want to get the most value out of this video, to go ahead and get yourself a free account, and then you can follow along with all of the tasks that I do so that it registers even better inside of your brain and you just get the most value out of it. So the introduction here tells us as such. So let me get a proper zoom going. Okay, so log analysis is an essential aspect of cybersecurity and system monitoring. At a high level, log analysis examines and interprets log event data generated by various sources like devices, applications, and systems to monitor metrics and identify security incidents. It involves collecting, parsing, and processing log files to turn data into actionable objectives by adopting an effective log analysis strategy. Security team, or I'm combining these sentences, so period. And then by adopting an effective log analysis strategy, security teams can more accurately respond to security incidents and gain proactive insights into potential threats. In this room, we will explore concepts related to log analysis methodology, effective logging practices, and common tools to aid detection and response. Our learning objectives are going to be to learn log analysis practices, best practices, discover the essential tools for analysis, gain hands-on experience in analyzing logs by using multiple tools and technologies. And the room prerequisites are the intro to logs room, which we've already done a video for, so you can go watch that if you haven't seen it already. It should be episode 1 in this entire series, and then log operations, which should be episode 2 in this entire series. So those are going to be your prerequisites to get this ball rolling. And that being taken care of, let's talk about some log analysis basics. Alright, so if you don't already know what logs are, which hopefully by now you do, so I'm not going to spend too much time on this. If you really want to know what logs are, I would say go to the intro to logs video. So I'm really not going to spend too much time on this. But this is basically what you'll see right here is one line item from a log file, right? So at the very beginning, we get to see the time and date right here. Then you get to see the IP address that this thing is associated with, and then you get some kind of a warning message, so you get to know what this actually, the type of log item it is. It's a warning and it's general, and it says unusual network activity detected from this IP address to IP source zone is going to be internal, destination zone is external, application web browsing action alert. So this seems like it might be a firewall. Yep, right here, exactly, very good. I'm getting better at this. I noticed that it was a firewall thing. So this seems like a firewall log, right? So it came from a firewall log. We got a warning message saying that there was an unusual activity detected, and it tells us where it's going from and where it's going to. And internal and external is what kind of gave it away for me, because internal and external is usually syntax that's referred to specifically for firewall logs. And that's basically it. You got an alert, right? So this is basically the alert right here, and it's saying that this particular IP address is trying to go here, and this is apparently either a denied IP address, or maybe this IP address isn't supposed to have any access to anything externally. So those are the kinds of things that would set off a firewall log, right? So the date right here, as we established, this is the system's IP address, the source that generated the actual log. This is the warning message, severity of the log, so it's a warning, which means it needs to be looked at very, very it's more important than informational, right? So we have 4 levels to this. We have informational, we have warning, there's an error message, and then there's a critical type of log item, and the critical ones are the ones that you got to address immediately, right? And so the action is an alert. So the firewall policy was configured to notify when something like that happens, and everything else just gives us more information specific to this thing, meaning that it was detected from this IP address and it's going to this IP address based on the source zone. The traffic appears destined for the internet, which is external, and the application was categorized as a web browsing type of an application. So the reason why this is important is that you get to do a lot of things with your log. So for example, if your system is crashing or if there's something wrong with your system, you get to troubleshoot what's going on in your system. And the log will help you do that because you can trace the steps as to where the troubleshooting error came from. The next thing would be there's a cybersecurity incident. So if something were to happen inside of the company that you're working at and you need to respond to an incident, the logs will help you figure it out. And for cybersecurity, there's a lot of different logs that you need to look at, and we call this correlation, where you connect the various logs to try to figure out what the overall incident was. And for that, you would use something like a security information and event manager, also known as a SIM, which would be Elasticstack or Splunk, and we have that set for the future videos that we're going to be doing in SOC Level 2. But, you know, cybersecurity incidents combine firewall logs, IDS logs, system authentication logs. All of those things combined give you the full picture of what's going on. And that way you can understand what the incident actually was doing, right? It's not one of those things is going to give you the full picture. You need all of those logs to get you the full picture, how to find malware, how to respond to an incident that just happened, how to backtrack and find the person that just attacked you, so on and so forth. Threat hunting is another thing that's really useful, right? So this is responsive, this is reactive. Threat hunting is proactive, right? So you're going after the threat, you're going after the person that attacked you so that you can prevent it from happening again, and maybe you can even find the person that actually attacked you, like something that happened to the MGM Grand where they were held at ransom, and it was like a really big attack that happened to them. I think it was like towards the end of 2023, and they were held at ransom for a very long time, and their entire casino was shut down in Las Vegas, and it was like a big deal. And so knowing how to hunt that person that attacked you and held you at ransom, I would assume would be like a big deal. I don't know if they actually did that, but I would assume that that's a big deal. And then of course there's compliance, which is a really big deal. So there's regulations that you got to adhere to, there's laws that you got to adhere to. There's a lot of compliance stuff that happens with every single freaking business. And the most basic one is GDPR, which is the General Data Protection Regulation. And it was founded in Europe, but if you do anything in Europe, meaning if your website sells to somebody in Europe or somebody in Europe Googled you and found your website from Europe, that means you have to adhere to the GDPR regulations. HIPAA has to do with anything health information related. So HIPAA stands for Health Insurance Portability and Accountability Act. So if you're in life insurance, health insurance, if you're a private practice doctor, if you're a hospital, anything that has to do with somebody's health insurance information, that applies to you. PCI has to do with payment card industry, digital security standards. So, which means if you're collecting any kind of payment card in any capacity, in your physical location, on a website, if you're dealing with payment card information, you have to adhere to the PCI standards. So compliance is a big deal, and logs help you do those types of things. And in the intro to logs video, we went through all the different types of logs, and this is kind of a snapshot review of it. So you have application logs for applications, you have audit logs that help you try to backtrack events or actions or any kind of changes that happen, security logs for security, server logs that has to do with specific servers, system logs has to do with the system itself, network logs have to do with the network, database has to do with databases, and web servers have to do with web servers. So these are the types of logs that you'll deal with, and there's a lot of different types of logs in addition to these things. These are just the most relevant to us as we're studying for cybersecurity, right? So these are the various types of logs that you deal with, and these are the reason why they're so important. And this was just a sample log that we looked at. So this, again, I skimmed through it. I burned through this information because I've already done a full video on the introduction to logs, so I'm not gonna spend a lot of time on this. So video, episode 1, episode 2, and episode 2A, or I don't know how I named them, but those 3 specific episodes will give you a really good introduction to this. And now we can actually go into the specific, the more, I guess not specific, but like the deeper details on the log analysis concepts, which is obviously investigation theory, detection engineering, and all the good stuff that comes with this. So let's jump into investigation theory. All right, to investigate, and this is more going to go, I think this applies both to reactive and proactive threat hunting and cybersecurity. But to investigate an incident, you need to look at several things, right? So there's the timeline. The timeline is the beginning and end of the whole thing. So when conducting a log analysis, creating a timeline is a fundamental aspect of understanding the sequence of events, right? So from the beginning to end, within systems, devices, applications, the network, all that stuff. So this is a high level kind of a perspective. And you're looking at the chronological representation of the events ordered based on their occurrence. So from the beginning to the end, this is the timeline of what just happened to this. And to be able to actually see what's going on is very important to give yourself a context, to give you a full picture, a big picture view of what just happened over a specific period of time. And then with incident response scenarios, it plays a very important role in reconstructing security incidents. So when something happened, knowing the timeline gives you an understanding, again, of the full image. That it's probably going to be like something that I'm going to hammer on over and over and over again. So the big picture is very important. The full image is important so that you understand the full concept of what just happened. When you have an effective timeline, security analysts can trace the sequence of events leading up to an incident, allowing them to identify the initial point of compromise and understand the attacker's tactics, techniques, and procedures, which is something that you will see a lot when you're studying for the CYSA exam and when you actually take your CYSA exam. So understanding tactics, techniques, and procedures is very, very important. So there's the timeline, and then we have the timestamp. So timestamp is something that is a base requirement for logs. So most logs will typically include a timestamp by default. Sometimes you may have to actually turn it on and make sure it's there. If you don't have a timestamp, you can't create a timeline. You see how that works? So with the potential of many distributed devices, applications, and systems generating individual log events across the regions, it's crucial to consider each log's time zone and format. Converting timestamps to a consistent time zone is necessary. Usually it's universal, so UTC. And it gives you it's a convenient way to do accurate log analysis and correlation, which means combining all of your logs across different log sources. Many log monitoring solutions solve this using time zone detection and automatic configuration. Splunk is one of them, and it automatically detects and processes time zones when data is indexed and researched, regardless of how many times or regardless of how time is specified in individual log events. Timestamps are converted to Unix time, and it's stored in the time field when it's indexed. And the consistent timestamp can be converted to a local time zone during visualization, depending on where the person is, where the analyst is that's looking at it, which makes reporting and analysis more efficient. And it ensures that the analyst can conduct accurate investigations and so on and so forth. Then there's something called a super timeline, which is something that I just learned about. So it's also known as a consolidated timeline. And it's a very powerful concept. Super timelines provide a comprehensive view of events across different systems, devices, and applications, allowing analysts to understand the sequence of events holistically. So across all of the devices that were involved, across all of the applications that were involved, all of the time stamps get combined, and you get a super timeline that gives you the full picture with all the devices, all the elements, and basically the endpoints and everything. It gives you basically everything. So it includes data from previously discussed log sources such as system logs, application, network traffic logs, firewall logs, and more. By combining these disparate sources, that's an interesting word, disparate sources into a single timeline, analysts can identify correlations and patterns that need to be apparent when analyzing logs individually. Creating a consolidated timeline with all this information manually would take time. Not only would you have to record timestamps for every file, but you would also need to understand the data storage methods of every application. And Plazo, the Python log2 timeline, very, very cool, I love Python, is an open source tool created by Kristen Gudjonsson, I hope I pronounced that right, and many contributors that automate the creation of timelines from various log sources. It's specifically designed for digital forensics and log analysis and can parse and process data from a wide range of sources to be unified and chronological. So very, very cool. And Playso is the official documentation page. Oops, I did not mean to do it in this window. My keyboard timed out and I got sent to instead of opening up a new window, there we go. So welcome to Playso documentation. So I mean, you can read through this. I'm not going to read through this right now, but there is a playso.readthedocs.io is what you can find that. Or you can just get yourself a free membership and just go inside this room and get that direct link. Data visualization is what makes this super freaking easy. If you're doing this to the command line, you can still make it easy. Or if you're just doing like a log line by line kind of analysis. But if you use something like Elasticstack, Kibana, or Splunk, you get a visualized format like this. And it's just, dude, it's so much easier. I mean, compare this to literally a black and white screen with line and line and line of code. I mean, who wants, not code, but you know what I mean, like log items. Like who wants to do all that? So what this does is it gives you the event IDs. It gives you the applications themselves. It gives you the processes that were used. It gives you so many things. It'll give you usernames. It'll give you the geolocations of where these things happened, the timeline that it happened, the number of moderate, high risk, or critical, everything. It gives you everything. This is the dashboard itself specifically, and then you click on any of these and you can go dig deeper and go further into the rabbit hole. And it's just, I mean, it's amazing. We call this the single pane of glass, which is the concept behind the dashboard. And you can customize your dashboard to show you the events that you think are more relevant to you, or the data that's more relevant to you, and it just makes your life way, way easier. So to create an effective visualization, you got to first understand the data and the sources that are collected and define clear objectives for what you're trying to visualize. So imagine that you're trying to monitor and detect patterns of increased fail login, and in that case you will want to visualize logs that have to do with login attempts from an authentication server or a user device. A good solution would be to create a line chart that displays the trend of failed login attempts over time. To manage the density of captured data, we can filter the visualization to show the past 7 days. That would give us a good understanding, good starting point to visualize these things. Then you have log monitoring and alerting, which is also another thing that happens with Splunk or Elasticstack, which gives you alerts. They'll monitor all of your logs in one place because you can connect all of your endpoints to Splunk or Elasticstack. And once you have all your endpoints connected, it monitors all of those endpoints. And if something of note happens, you'll get an alert on your screen, especially if you've set up your dashboard to show you those specific things. And events that are worth creating alerts for could be multiple failed login attempts, privilege escalation, access to sensitive files, or other indicators, or trying to access sensitive ports that shouldn't have been accessed, all that stuff. So alert that the security team are promptly notified of suspicious activities that require immediate action. That's what alerts do. The roles and responsibilities would be defined for these things. So for escalation and notification procedures, those would be defined for various stages of the incident response process. So if somebody notices it, they'll probably send it up to their immediate supervisor, which if it's really important, they'll send up to the manager, so on and so forth. And eventually it might even get up to the CISO, right? The Chief Information Security Officer. So there's a hands-on walkthrough for this, for Splunk dashboards and reports room, which I think we've already done. Oh, we haven't done this, but okay. I mean, it's not that big. It's not that big of a deal because it's just the Splunk dashboards and reports, and we're going to get a really good understanding of it, or at least a good a sample of it, especially when we go into the advanced videos for this particular pathway. But I've done multiple videos on Splunk already, so you can go ahead and check those out to see what the Splunk dashboard looks like, to see what basic event monitoring looks like. I feel like I should have already done this, but okay, it's all good, no big deal. Then we have external search and threat intelligence. So identifying what may be of interest is very important. And first you got to understand what threat intelligence actually is and where you can go find the information like that. So Virus Total, for example, is a website that has a bunch of different IP addresses, URLs, files, file hashes, all of those things inside of its database, and you can go there to compare an IP address versus their database to see if an IP address is a threat, right? So that's a threat intelligence tool that you can use. And there's the overall concept is pieces of information that can be attributed to a malicious actor, and it could be IP addresses, file hashes, domain names, so on and so forth. So when you analyze a log file, you can search for the presence of these things. For example, this web server log, which is right here, you can see that the IP address has tried to access our site's admin panel, right? So when you look at this whole thing, let's see, so cat access log is the command that shows it to us, and we have these various line items. And so if we were to try to sift and sort through this thing, we can try to see, because they said they try to access the admin room. So let's see if we can actually find that in here. So first one, this is the timestamp, get admin. There you go, get admin, HTTP, and it was successful because 200 is a success message. They used the Mozilla compatible, so on and so forth, robot file. And then this is another one, get TryHackMe room docker rodeo yada 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 catalog, one PNG, and that seemed to be successful as well. And then get TryHackMe, I don't know what this is. This seems to be an injection that they put inside of the URL to try to get some information. And again, this came out successful for them. And then another request to TryHackMe designs. Again, this was successful, right? So using threat intelligence like ThreatFox, we can search the logs for known malicious actors' presence. So ThreatFox, I'm assuming, is kind of like VirusTotal, right? So if I go here, ThreatFox database, look at that. And then you can go look at this. You can search for a bunch of different things. So search the syntax seen below, example, malware, zloader, and all that stuff. So that is another cool tool, which I did not know about. And so you can search for the malicious actor's presence, and it gives you in IOCs an indicator of compromise. The malware names are here, the tags are attached to them, and the people who reported them are all here as well. So if we search for this IP address inside of the log file, you'll see, I mean, I guess they just searched for that and it just gave them that. So it's not that big of a deal. So it says, what's the term for a consolidated chronological view of logged events from diverse sources, including or often used in log analysis and digital? I would say that is the super timeline, right? Yeah, super timeline. Which threat intelligence indicator would this hash and this hash be classified as? So we're going to copy this, and we're going to go to ThreatFox, and we're going to, let me see if I just paste this, if this will work. No syntax. Let's see. Oh, I see. So I was actually trying to find this specific hash, I guess what these hashes are connected to. I knew that these were hashes, but I think what they're trying to do is they're trying to go over here. So right here it says external research and threat intel. What is the indicator, right? So this is the types of indicators. So IP, So file hashes would be the specific answer that we're going to be looking for. And there we go. Okay, cool. That is all good. All right, so now we can move on to the next one. Damn, this is a long one. Okay, cool. We got detection engineering, which is the current piece right here. All right, so we got common file locations here. So web server log locations on an Nginx web server for access logs would be, and these are all Linux. So this just by itself, you can kind of determine that these are Linux computers or Linux machines that you're looking through. And so they would just have the Nginx would be the directory, and inside of that directory would have your different logs. And same thing with Apache, and so on and so forth. And so databases, MySQL, you'll notice that, you know, Verilog, all that stuff is where it is. And then you have MySQL, Errorlog, and then Verilog PostgreSQL. So if it was a PostgreSQL database versus MySQL database, same thing. Web applications, Verilog, PHP, Errorlog, syslog, authentication log, IP tables log. Snort has its own directory, so you can have snort logs, or you can just dedicate it to be in whatever directory that you want, but it just makes it more convenient and easier to track down and transfer to other analysts if you just keep the same directory for the snort logs. So these are common, but it's important to understand that the actual paths could be different based on the system configurations, the software versions, and anything of the sort. So it's recommended to consult the official documentation for this. And then there are common patterns. So Common patterns and trends in log data is important for identifying potential threats. These patterns refer to the identifiable artifacts left behind in logs by threat actors or cybersecurity incidents. Fortunately, there are some common patterns that, if learned, will improve your detection abilities and allow you to respond efficiently. Abnormal user behavior is considered to be an anomaly. So one of the primary things that show up is unusual or anomalous user behavior, and this refers to any actions or activity that deviate from the typical or expected behavior, or also known as the baseline. So to effectively detect anomalous behavior, organizations can employ log analysis solutions that incorporate detection engines and machine learning algorithms to establish normal behavior patterns. Deviations from these patterns, or baselines, can then be alerted as potential security incidents. So Splunk user behavior and analytics is one of them, IBM QRadar is another one, and Azure AD identity protection is another one. So Splunk, you already know. IBM QRadar is the SIM for IBM, and then Azure is the Microsoft Cloud environment, and AD is Active Directory. So Azure AD Identity Protection, these are all great solutions to this specific concept of detecting abnormal user behavior. And abnormal user behavior could be anything like this. So multiple failed login attempts, unusual login times. So somebody tries to log in outside of normal business hours, for example, or outside of their regular operational hours, 3 in the morning. It's like, okay, what are you doing trying to log in at 3 in the morning? Geographic anomalies from IP addresses in countries the user doesn't usually have access to. So that's another thing which can be combined with the unusual login time. Frequent password changes. So if a user's password has been changed frequently in a short period, may suggest an attempt to hide unauthorized access or take over an account. And unusual user agent strings. So in the context of HTTP traffic, requests from users with uncommon user agent strings that deviate from their typical browser may indicate automated attacks or malicious activities. For example, by default, the Nmap scanner will log a user agent containing Nmap scripting engine. The Hydra brute forcing tool by default will include Hydra in the user agent, and these indicators can be useful in files. So if you are scanning somebody, basically, using Nmap, it's going to say Nmap scripting engine inside of the user agent description. If you use Hydra brute forcing, by default it's going to include Hydra in its user agent. And if you want, on the pen testing side, if you don't want to be detected, you need to change that, right? But by default, it's going to say Hydra, and Hydra is a brute force web application password hacker, right? So the significance can greatly differ or vary greatly depending on the specific context and the systems in place. So it's essential to fine-tune any automated anomaly detection to minimize false positives. Common attack signatures is also another one of those things that, just based on the databases that are available, and a lot of these tools have those databases ingrained in them already. They're embedded already, so they can detect attacks that are happening based on the attack signatures that are going on. So anything like malware, web-based attacks, SQL injection, cross-site scripting, directory traversal, all those things have signatures that are already inside of a bunch of databases. So depending on what you use, it'll show up as that signature. So for example, SQL injection exploits vulnerabilities in a web app that interact with databases, hence the name SQL. So looking for unusual or malformed SQL queries in the application can identify an injection attack. The suspicious queries could contain unexpected characters, like a single quote could be one of those things. Somebody just does a single quote, or somebody tries to do a comment, or one of these things. Union statements, time-based attacks, all of these things are hints that somebody's trying to do some kind of an SQL attack against you. And if you don't know what that means, definitely go and check the pen testing videos that are on the channel. And I want to create a lot more videos around this topic because it's a very interesting topic. But there are videos that we've done SQL attacks, SQL injection attacks, and you can definitely go check those out. We have an SQL injection attempt by doing the single quote followed by union select, and then it's part of the query parameter. And the attacker appears to have escaped the SQL query with a single quote and injected a union select statement to retrieve information from the users table. So this is the original thing, right? So this is the full thing. Get products PHP, Q books, right? And then you see how there is a double quote right here. So that's the beginner, the beginning part of this entire thing. And so they do the command right here. A single quote will end this, or essentially what it does is it escapes the previous thing, and it does a union, and it then combines it. So selecting nothing and nothing from username, and then getting the passwords nothing from users, right? So excuse me, not from username. So selecting nothing, nothing, username and password, nothing from the user's database, and then doing this piece right here to comment it out and make sure that the rest of it actually goes through, and then they get a 200 success, meaning that they actually were able to pull that information. They were able to get all the usernames and passwords from the user's database. So, or the user's table, I should say, not the user's database, the user's table. Cross-site scripting allows people to inject malicious scripts into the web page. And XSS attacks, it's often helpful to look for something that has script in it, because they're trying to insert scripts. So on mouse over, on click, on error, right? A useful XSS payload list to reference can be found here. So let's see what this is. Oh, this is a GitHub repository that has a bunch of different XSS scripts for the intruder. So this is a cool one. This is something that I would recommend that you check for. And these are some of the things that you can do. XSS strike or XS strike, whatever, brood XS, etc., etc., etc. And there are good info there for you to reference. And this is an example right here. So you have, again, the same thing, and then search equals, so get products.php, and then search, and then they inserted this script at the end of it right here. And this basically just puts something onto the screen that says alert. That's not that big of a deal, but they injected a script right here. And that's it. It opens with a script inside of these brackets, and then you have a bracket / script. So just noticing this, you can tell that this is the script. And if you want to see what the script is trying to do, you just find all of the information between these two right here, and you can get a good understanding, or at least you can find the body of the script, and then you can go to some kind of an AI tool and say, hey, what is this script trying to do, right? So path traversal is another one of those things that once they get inside of a web server, they're just trying to get up the web server, traverse up the web server. So when you do CD, and I'll show you this actually, because this might be a little bit easier to demonstrate by doing this, right? So if I open up a terminal, and this is my current path right here. All right, so this is going to be my current path, which is the root path. Let me zoom in a little bit for you. Inside of the root path, we have all of these files right here, and some directories. The stuff in the blue is a directory. So if I go into the desktop, there is a bunch of stuff inside of the desktop, and then so there's tools on the desktop, and I can go inside of tools, and then there's a bunch of stuff inside of here, and then I can go to PAS, for example, and now we have a bunch of stuff right here. And now you see that my command line has now changed into this, right? So if I wanted to get back into the root folder, into my main folder, I would do cd .. // ... right? So the first one gets me out of this, the next one gets me out of this, and next one gets me out of this, and gets me all the way back to the root folder. And I just press enter, and now I'm back in the root folder, and you press ls, and now you're inside of the root folder, right? So you can do the same thing inside of a web server by putting it inside of the actual get request of the website, or maybe even inside of the URL at the very top right here, right? So the person that did this right here after the products PHP type of thing, they could probably just do it over there. Like we've done that on server-side request forgeries, where we just put the .. this is not an ellipsis, because ellipsis would be 3 dots, but the .. / it just keeps taking you higher up the path until you get inside of the root folder, and then from there you can keep going. So this one is going up what, 2, 3, 4, 5 levels. They're going up 5 levels to try to get to where they are, and then they're going to get the etc password file, because the etc password file shows us all of the etc password it shows up all of the usernames. It doesn't give you all of the passwords, but it'll give you all the usernames. And then you have, the username Whoopsie, and then you have Pulse, and then you have whatever, Iodine, all these different people, and it tells you what group they belong to. And if we scroll up a little bit, and we'll find the root user, so you see the root user, the daemon user, the system user, all these different users that are here, and it gives you the general information. So you don't get all the information about their passwords, but you do get their actual username information and some other useful stuff about them as well. So these are the various types of attacks that can be done that you could potentially detect while you're going through your logs. So the question here says, what is the default path to view logs regarding HTTP requests on an Nginx server? So the default path would be verilog Nginx, and then I'm going to say, what is that? Would it be http.log? Let's see, do we have the example over here? Let me see if I have it over here. Maybe that would be cool. So let's see if we can go to the cd verilog Nginx. Do we have that? No, we don't have that over here. Okay, I'm just going to take a guess here, and I'll probably do http.log and see if that works. Okay, so http.log is definitely not going to work. So what I'm going to do, I'm just going to Google this actually. And, oh, okay, it's access.log. So we can just go and change this to access. Let me see if that works. There you go. Access.log is the default path for that. Okay, not bad. Easy to find. Now this one says a log entry containing this was identified. What kind of attack does this look like? So let's see. All right, so here's a little trick for you, okay? Based on this, I just know that this information right here, this looks like an URL encoded line of information. So I went to CyberChef, which is one of our favorite tools here. I pasted it inside of the input right here, and then I put URL decode, and automatically it gave me the information. And we have ... proc self environ, which means, just based on the ... so this is a path traversal attack, like that, just like that. Easy money. So there we go. We got some good information on detection engineering. So now let's go into automated and analysis, manual analysis. And I think the very next one, yeah, that's when we're going to start doing some actual exercises here. So that should be fun to do. All right, so automated versus manual analysis. Automated analysis, as you can imagine, involves tools or scripting or something like that. So it could be something like XPLG, SolarWinds, Logly. Automated tools allow for processing and data of analysis of logs, and they often use AI or machine learning to analyze patterns and trends. What can happen is that you can have false positives, right? So the advantage is it saves time, right? The use of artificial intelligence is effective because it recognizes patterns and can do it much faster than a normal human being. But the disadvantage is that they're usually either commercial only, which are expensive, but again, you could just go to ChatGPT and drop in your log file as an attachment, and it could try to analyze it for you, and that's for free. So that part is cool. But the effectiveness is depending on how capable it is, and then false positives right here. So false positives is a big deal. Like it'll just it'll think that any smoke means that there's fire going on. It'll give meaning to things that don't necessarily have to have meaning, or it'll miss things. So a false negative would be one of those things where it says, oh, this is nothing to worry about, but it actually is something to worry about. So it's good, it has advantages, but it shouldn't replace manual analysis. So manual analysis it's cheaper because you don't need expensive tools, although that could also be argued, because paying for a security analyst to do something like this, it takes, you have to pay them, so it might take them a lot of time to do it. But simple Linux commands, if you know how to use the Linux command line, you could actually sift and sort through files pretty quickly. I did it in the last video using the command line, and it was really quick. So if you know how to do the command line whether Windows or Linux, you can sift through log files pretty quickly and try to find the information. But again, you have to do a lot of sifting and sorting through. So it's time consuming. So it's one of those things that the AI could do it so much faster, and the analyst needs to sift and sort through each log file to try to and find them and try to connect all of the dots, right? There's a thorough investigation that's an advantage that there's literally no disadvantage for this specific line item, because I mean, you get to look at everything and you get to put all the dots together, and you're much more thorough than what an AI could be, because the AI is looking for patterns and things like that that already exist, because it's been trained on data that already exists. So if there's a 0-day attack that's been done, which means an attack that has never been used before, then the AI is most likely not going to be able to tell, because it's looking for signatures that already exist in databases and its own data sets, and that's what it's basing its search and analysis on. It reduces the risk of overfitting or false positives on alerts from automated tools. Events or alerts could be missed, right? So this is the other piece, right? If it's a big log file, if there's a lot of information in the log file, the AI is most likely not going to miss something, because it's very, very good. It's going to go line by line through everything. The human being can probably miss it. And that's the part that is one of the big disadvantages of using a human being to go through a lot of log files. Then you have contextual analysis that a human being can do. They have a broader understanding of the organization and cybersecurity landscape, whereas the AI would probably need to be trained for a long time to establish a really good baseline to be able to do that. But the human being can already do that pretty quickly, because they already have the understanding. And there's no disadvantage to that specifically. But the big part of this is that it is very time consuming for a human being to do this. And this side, it's so much faster to do it, but it can give you false positives, false negatives. It could be expensive because you have to buy this expensive tool, so on and so forth. So our question here is: a log file is processed by a tool which returns an output. What form of analysis is this? So it's reviewed by a tool, so it would be automatic. And an analyst, is that wrong? What form of analysis? A log file is processed by a tool which returns an output. What form of analysis is this? Is that wrong? What? How's that wrong? Oh, automated. Oh my god, dude, are you kidding me? Automated. There you go. And an analyst opens the log file and searches for events. What form of analysis is this? That would be manual, and not manula, manual. Very good. Alright, cool. We are now done with this, and now we can go into our specific tool right here. So very cool. Alright, cool. So the first one that we're going to be dealing with is the Apache log that is inside of this room already. If you're going to be using your own Linux machine to connect via VPN to the servers at TryHackMe, you can download these task files, but for us they already have it over here. So I'm just going to go to this specific directory, and I'm going to find that Apache log, and then we're just going to run our commands right here so we can find this information, and we'll probably be able to answer some questions at the very bottom using these pieces of info, right? So it says use cut on the Apache log file to return only the URLs. What is the flag that is returned in one of the unique entries, and in the log find how many total HTTP 200 responses were logged, so we got to count that. Which IP addresses generated the most traffic, we got to find that. And what is the complete timestamp of the entry where this thing accessed login.php. So I'm going to keep all of those things in mind, and as we go through all of these commands, we'll find those answers. So at the very, very top here, the first command that we're going to do is cat, which basically means concatenate, and it's going to list everything that is inside of that log. So first, let me just go into the directory that has it, intro log analysis task 6, and there we go. And so if I do ls, there's only one log in here. So if I just do cat apache.log, we'll see that we have the full thing, right? We have the full output of the log file, and there's so much that it literally I mean, this would be a lot to just sift and sort through, and it can be intimidating, right? This is a lot. This is a lot of information, and I don't want to sit here line by line reading through that whole thing. So the first command that we can do is you do less apache.log. And when you do this, it displays the first page by default, and then you can just scroll down using the arrow keys or with page up and page down, and it'll give you the next page and then the next page. So it makes it a little bit easier to read instead of kind of scrolling through a bunch of data like this. So if I just did less apache.log, now you see that it gives me this thing right here, and it's just one page. You see it won't like scroll up and down or anything like that. So I can just do, or actually I think when I scroll it does do that. So if I just do page up like that, it'll take me through all the data that was previously there. And so this is the very top. So this is the first set of data, then this is the next one, then this is the next one, then this is the next one, so on and so forth. So there you go. I think it's kind of registering late, but you get the idea, right? So for each page, because you see that this doesn't, like, there is no space for the scroll bar to go, so it means that just on this specific screen I'm getting a certain number of output, and then if I just do this, it'll get me the next set of output, and so on and so forth. So that's what less does, right? It gives it to you one page at a time. Now tail, what it's going to do is going to give you the end of the file, and it typically gives you the 10 results at the very end of the file, and it's typically coupled with the F option, which allows you to follow the log file in real time because it's continually updating the terminal window new log entries as they're generated. So this is very useful when you're doing live events, but in our particular situation, I don't think this is a live event. I think it's just a pre-established log that they gave us. So it's going to only show us the last 10 lines of the file, and we can change this with the N option to only give us this certain number of files. So in this case, it's only going to give us 5 lines, right? So this is going to be live 5 lines from the Apache log. So I'm going to go ahead and do that now. So if I do Q, or if I do, what is it, escape or Q? How do we get out of this? I'll do Control C. I think it was probably Q actually. So we're going to clear the screen here, and I'm going to do tail F N5, and I'm going to do Apache log, and there we go. And now it's going to give me 5 lines, right? Very easy. But I don't think this is being updated in real time, so I don't think that these 5 lines are going to change or be updated in any way. But it's a good habit to just have the F as a part of your tail command, so it's just constantly giving you the most recent ones. It's following the path of this log file, and it just keeps giving you the most recent inquiries or the most recent line items that come through the log. So tail F N5 Apache log, and that's what we got. And now there's a little note right here that says the opposite of tail is head. Head gives you the top of the file, so the first 10 lines, and same thing, right? So you can get the first 10 lines or the first 5 lines or the first whatever from a file. The tail gives you the most recent events that are coming in place, because when you look at the file, the top of the file is the very beginning of the events, and the bottom of the file is the most recent, the latest events that happened. So typically tail, I feel like, would be better if you're trying to find recent events, right? Or if you're just trying to get to the end of the file and find especially if it's like a giant file, or if it's a giant file and you're trying to get to the top of the file but the terminal doesn't show it to you. Sometimes it does that. This time it didn't do that because I was able to see the very top of the file, but sometimes the file is so big that no matter how high I scroll inside of this thing, it won't show me the very top of the file. It just stops at a certain point, and that ends up being something that is very inconvenient, especially if you're trying to find what happened at the very beginning. So then we got something called word count. The WC command is a very important thing, and it doesn't give you any other result other than the word count, right? So after running this, you can determine that the file contains 70 lines with 1562 individual words separated by white spaces and 14,000 individual characters. So these are the words, these aren't characters, and then there's 14,000 individual characters. So let's compare it to see if this is actually what we got based on this thing. So let me get that out. So if I do wc apache.log, it'll actually exactly the same, right? So 70, 1562, 14305. Is it 14305 here? Yeah, 14305 here too. So exactly the same input. So they're looking exactly at the same file here. So now we're going to look at the cut command. So it extracts specific columns or fields from the file based on specified delimiters. And this is very handy if you're working with log files that have structured or tab separated data. If it's not structured, it's probably useless. It's not going to work. So if we want to extract all of the IP addresses in the file, we can do cut to specify a delimiter of a space and only select the first field that's been returned. So what's important is for us to understand what actually is at the very, very top of the file, so we can kind of see what this whole thing does. So if I do head, I'll just do head and I'll leave it at the 10 lines, and I'll do apache.log. Hopefully it'll actually show us the very, very top of the file, and we can see, no, it doesn't give us that. So it doesn't give us the field names, but what we can see just from the pattern of the information that's here is that the first item is the IP address, the next item is going to be the timestamp, and then the next item is going to be whatever command that we're sending, and then you have the result code that was given to us, and you have the user agent, and this is the actual event ID probably, so on and so forth, right? So if I wanted to pull all the IP addresses, I would just look at the very first line item, which is exactly what they did over here. So cut D, and the delimiter is going to be a space, in this particular case field number 1 from the Apache log. So I'm going to go here, I'm going to do cut D. Oh man, my computer is tripping right now. I think it's the connection to this virtual machine. So if I do cut, there we go, D, we'll do a space as the delimiter, and we're going to do field number 1, and then we're going to do apache.log, and key me an enter. Okay, cool, there we go. And we got all of the IP addresses that were cut from this entire thing right here. And then you can combine this with probably the next thing that they're going to tell us about, which is sort. There you go. Sort, and then there's another one that should be unique. And then there should be sed for log analysis. Let me see, is there a count? Should be count in here somewhere. I wonder if we're going to do it. Okay, so never mind. So we're going to do, what is it? The next one is going to be sort, which is going to take it from the smallest to the largest, I think. So sometimes it's helpful to sort the return entries chronologically or alphabetically. The sort command arranges data in files ascending or descending based on the specific criteria. It's very crucial for identifying trends. It's also common to combine the output of it or output of another command, so for example cut, and then use it as the input using pipe. So when you use pipe, this thing right here, it takes the output of this command and then it sends the output of this as the input of this, right? So you take the output of this command and you send it as an input into sort, and it'll now sort it. You see how it shows you everything in perfect order. So if I do cut, and then I'm just gonna literally press up in my tab right here, and then I'm just gonna pipe that result into sort, and we're gonna do in this particular case, and it's going to sort these things numerically for us. And so we see right here, let me just kind of extend this a little bit for us, and we see that we have all of these IP addresses that are here, and they've all been sorted numerically from the smallest to the largest. So 76.89 is going to be smaller than 104.76, right? So 104 is greater than 77 or 99, right? That's how this thing works. And then 110 is greater than that, right? So you see how it's going ascending order, and it gets to the 200s, so on and so forth. And there is a question at the bottom right here that's telling us, it says use cut to return only the URLs. What is the flag that is returned in one of the URL entries? Then in Apache, how many total HTTP 200 responses were logged? And then in Apache, which IP addresses generated the most traffic, and so on and so forth. So it's not going to be on the IP addresses, but we do want to return the URLs specifically. So what I'm going to do one more time is I'm going to do head, and I'm going to read the Apache log file one more time, just so I can find out what field the IP address is in. And in this case, I believe because this seems like an empty field, so I don't know if this is, we're going to count this as 1. So this will be 1, this will be 2, this will be 3, this will be 4, from what I can tell. Yeah, so this will be 4. And then this is going to be 5, that'll be 6, and this is going to be 7, which will be the last thing. So number 4 will probably end up being our pool of the IP address. So now what we're going to do is we're going to do the previous command, and we're going to search for field number 4. And what's the question one more time? It says, what is the flag that is returned in one of the unique entries? So only return the URLs and look for a flag that is inside the unique entries. So we need to combine cut, we need to look at 4, and then we need to find the unique entries, which is where this comes into right here. So this is the last piece, or not the last piece, but this is the very next piece right here. So you look at cut, delimiter space, field number 1, we're going to do field number 4, and then we're going to sort it numerically. And R in this particular case, let's see what R stands for. Okay, so here we go. So we have sort n, so it gives it to us numerically. And then you have R that can be the reverse version of this. So instead of doing numerically ascending, it'll be numerically descending. So it reverses the order, it gives you the large one first. And then there's another one that comes down with this, which is the unique, right? So you have the same cut command, then you have sort nr, and then you have unique, and it gives you all of the unique IP addresses that showed up. And then you do unique C, and it'll count the number of times that these IP addresses showed up, right? So this is going to be something that's going to be right here, because it says how many total HTTP 200 responses were logged, which is going to be this field right here that has all the 200 responses in here. And then it says only return the URLs. What is the flag that is returned on one of the unique entries? So let's try to find that one here. So we're going to use our unique information right here. So first I'm going to do cut, then I'm going to do D, and we're going to separate it by delimiters, and it's going to be field number 4, which I believe is the field that has all of the domain names, or the URLs that are being pulled. And we're going to pipe that into our sort command, and sort doesn't need to do it numerically because they're not numeric, right? So we're going to sort it, and we're just going to do unique, and I'll even do count to see what shows up. And okay, so number 4 is definitely not the URL. Number 4 is giving me the date. So if this is number 4 and it ends right here, so this could be number 5. Oh, I see. So this is going by the delimiter, which is space, right? So this is 1 space, this will be 2 space, this will be 3 space. So this will be item number 4, and then that'll be another space. So this will be number 5, that'll be another space, and that'll be number 6, and that's another space, and that'll be number 7. So it's actually going to be number 7 because we're using the space as the delimiter. So we're going to go back here, and we're actually going to go all the way back here, and we're going to do space number 7, and that should give us all of our IPs. Look at that. Okay, cool. So there we go. And so this is the flag right here. Flag equals yada yada yada. So we're going to copy that, and I'm going to come down here, and I'm going to paste this mofo in here, and voila. Great. So in the Apache log file, how many HTTP 200 responses were logged? So field number 7 gave us that, which means after that space is going to be HTTP. So this will be field number 8. And then we have another space, and this will be field number 9. So the responses are going to be field number 9. So I'm just going to do exactly the same thing here, and we're going to go sort, and then we're going to do field number 9, press enter, and you got 52 200 responses, and you got 19 404 responses. So 52, voila. And which IP address generated the most traffic? So that's going to be field number 1. And let's go, and we're just going to mess with the same exact thing now, and we're just going to do field number 1. Press enter, and you got all of these things. And let me see which one gave us the most. So we have 6 here, we have 6 here, 6. This one is 8, so that's the highest one so far. And yeah, I think the one that has 8. So 8 is the one that has the highest count. So we're gonna copy this thing right here and go boom. There we go. And what is the complete timestamp of the entry when accessed login.php? So this one, I'm going to try to see if there's other information that we can find over here, which I think is going to be actually using probably grep and some of the other stuff right here, because I got a little bit, I mean, we got a lot of information just learning how to use unique and sort. So that was very, very useful. I love this stuff. Like, this makes it so freaking cool for me. So okay, so now we have sed, S-E-D, and AWK, which I think is the next one right here. So sed and awk are powerful text processing tools commonly used for log analysis. They are sometimes used interchangeably, but both commands have their use cases and can allow security analysts to manipulate, extract, and transform data efficiently. So using the substitute syntax sed can replace specific patterns or strings into log entries. For example, to replace all occurrences of this with July this in the Apache log, we can do this. You can do sed, oh, I see, and so this is a regex type of a situation, and then now it's going to replace all of these instances with July 31. And so there you go, you see July 31, 2023, so on and so forth. That's pretty crazy. So notice the backslash character is required to escape the forward slash in our pattern, and tell sed to treat the forward slash as a literal character. Also note that it does not change the log file directly. Instead, it only outputs the modified version of the file into the command line. So for example, if you want to overwrite the file, you can add the -i option to edit the file in place, or use a redirect operator to save the output of the original file. If you use this, it's going to risk overwriting the original data, so just be careful. And then the awk command is a common use case, and it's conditional based on the specific field value. So for example, to print log entries where the HTTP response code is greater than or equal to 400, we can use the following, right? So anything greater than 400 would be an error status. So if you do awk field 9, because field 9 is where we had all of the response codes, is greater than equal to 400, it'll only show you 404, what's this one right here, 404, so on and so forth, 404. So it only shows those, right? In this case, we're using the number 9, the $9, which is the log example for HTTP status codes, requiring that it's greater than or equal to 400. And now you have grep, which is a search tool that you can use it to search through files. So you grep admin apache.log, and it'll show you everything that has to do with admin. So as long as the word admin is in here somewhere, look at that, admin is in there somewhere, and it can do it. So if you do unique count, so grep admin apache.log with count, which it doesn't show right here. Oh, actually, no, I'm sorry, it's right here. So count. So you can do count with grep. So instead of it showing you the actual result, it'll just count the number of times that admin has showed up inside of this thing. And if you wanted to know which line number the log file relates to this, you can do grep n admin, and it'll give you the line number that this is attached to as well, which is at the very beginning right here. So on line 37, this is the thing that gives you admin inside of it. And then you can invert the command using the V option only to select the lines that don't contain a pattern or keyword. So for example, if you want to show everything that doesn't include index.php, then you do that, and then you can grep this from it, right? So you grep inverted this apache.log, and then from all of those results, I want you to grep this specific IP address, which is probably what we're going to end up using to find our final answer right here. So it says, what is the complete timestamp of the entry where 110 accessed login.php, right? So let's do this in totality. So what we're going to do is we're going to grep for login.php, and we're going to do it from the apache.log file, and we're going to pipe that into another grep command that's going to search for 110, 122, 65, 76, and see what we get. And you get one result only. And if we really wanted to be fancy with it, we can even cut the field from it. So this is the IP address, so that's field number 1, space, field number 2, space, field number 3, space. This would be field number 4, right? So if I do, I'm gonna do, what do? I do cut, and I'm gonna do the delimiter is gonna be spaces, and it's gonna be field number 4. I think that's what it was, right? Field number 1, 2, 3, 4. Yeah. So field number 4, and it's going to be from apache.log, and then we're going to grep /login dot, or maybe I should be doing this backwards. Let's try it. Let's see what it works. Login.php. Let me see if that works. It doesn't work, so that's not going to work. So first I'm going to do grep login. I'll actually do this whole thing. So boom, do the full thing, and then we're gonna go ahead and cut that using the delimiter of spaces, and it's gonna be field number 4, and let me see if that brings it. Boom, it got it. Nice. That is super cool. So I'm just gonna take that full thing, and we're gonna copy that, we're gonna paste that, and that should be good. Oh no, so what am I missing here? So let's see. Oh, I need the full thing. So F4, it needs to be everything at the end right here too. So I wonder how we can do that actually. Maybe it could be 4 and 5. So let's see. If we do F4 space or comma 5, fields are numbered from 1 to cut. Okay, I see. So yeah, I guess you can't do that full separator. I would need to find a different type of delimiter, I guess, to be able to make that happen. But there is our answer. Sweet. That was cool. That was fun to do. I hope you learned a lot from that. That was really fun to do. I'm very excited about that. All right, so now we're gonna go through regular expressions. This is a little tough one because regular expressions for me is not super easy to do. It's not super comfortable to do. So we are going to now use regular expressions in our grepping, in our searching. Alright, so regular expressions, also known as regex, are actually really important. They're very, very useful for searching, matching, manipulating data. As you saw the example that we did with the date, or I mean, I didn't do it, but that is a version of regex. That // thing is a version of this. So they're widely used in log analysis to extract relevant information, filter data, identify patterns, which is really big deal. So it's like, I want you to send me something that looks like this pattern, and process logs before they're forwarded to centralized SIM systems. It's even possible to use this with the grep command because it's a really great way to search for patterns. So what we're going to do is we're going to use this specific log file that's inside task 7 and ensure the unzip to unzip the file by running unzip regex.zip, and then go into the regex. Okay, good to know. And then we're going to start grepping through things. So let me traverse up 1. You see, we talked about traversal. See that? So traverse up 1. Now we're inside log analysis. We can do this, and then we have task 7. So we're going to do cd task 7, and we're inside of this, and there's a zip file that we get to unzip. So we're going to do unzip regex unzip, and then boom, we're like that, and now we have that. And now we're going to go into the cd of regex, and now we're inside of this thing. And now inside of this we have 2 files. We have the Apache, and then we have the email file. So in this particular case, what we've done is we've grepped this specific regex pattern from the log file, and it shows us everything that, I guess, let me see. Let's see what it says. So it says we added the E option to signify that we are searching on a pattern that rather than just a string. So we're searching for a pattern. That's what the E option does. It allows us to do regex. For the pattern itself, we match the literal characters post equals, after which we included the number 1 followed by the dynamic insertion of 0 to 9, including this. Putting this together means 1 bracket 09 bracket, which will match any 2-digit number that starts with 1, such as 10, 11, 12, and onward. So if we go over here, let's see what it does. What does it show us? So, oh, I see. So it says post 19, post 17, post 13, right? So it's searching for literally post equals 1, and then this is where the regex portion comes in, and it searches for anything from 0 to 9. So it'll give you post 12, post 11, etc., etc. Putting this together, it'll match that, and regular expressions for log parsing. So you can use this obviously for log parsing, and you can create custom regex patterns tailored to specific logs to map something so that's available for a SIM system. So consider the following: raw unstructured data, which is this thing right here. And so you have the IP address, the timestamp, HTTP method, the URL, the user agent, so on and so forth. So regexer is an online tool to help teach, build, and test regular expression patterns. This is actually really freaking useful. I'm definitely going to use that. This is the website right here. So very cool. I am super excited about this. I'm definitely going to use that. So it helps you teach, build, and test regular expression patterns. To follow along, copy the above log entry and paste it into the text section of the tool. So I'm going to take this, and we're going to copy this, and we're going to go here, and this is the text section, I'm guessing, right? Okay. Was that it? Yeah, because that's the expression up here. So this is the text section. Do I press enter? No? Alright, so we pasted it. Looks like this. As a basic example, if we want to extract just the remote IP address from this log, we can think about the structure of the IP address logically. The IP address is the log entry's first part, consisting of 4 octets separated by periods. We can use the following pattern: \B 0 to 9. Oh my gosh. See, this is where it becomes like, oh my gosh. So this whole thing right here is one piece, and then this is another thing. Alright, so paste this pattern into the expression field in the regex, and you'll notice that the IP address from the log is successfully extracted and highlighted. Yeah, this is something that I definitely have to study, because regular expressions is not my strength. So I'm gonna go here, and alright, so just like that, the pattern is highlighted right here. So this was the pattern, and we used this pattern, and we got this specific thing. Okay, alright, that worked. So breaking the pattern down, it begins and ends with a word boundary anchor to ensure that we match complete IP addresses. In between, we define the following. So you have 0 to 9 in brackets, and then you have 1 comma 3 for inside the squiggly brackets. So it says match 1 to 3 digits to match numbers from 0 to 999, while IPv4 addresses cannot exceed 255. This simplified pattern works for our use case. Then the \dot escapes and matches a literal dot in the IP address, and then bracket 3, which is the third piece right here. So we got all of this, and then you got bracket 3 specifies that the previous capturing group, which was this full thing that we had, should be repeated 3 times. Okay, and then you have 0 to 9 in brackets again, and 1 to 3 again, and this matches numbers from one another, completing the 4th octet of the IP address. Okay, so example, Logstash and Grok. Grok is Grok, isn't that like the AI from Tesla? I thought it was. Okay, so Grok is a powerful Logstash plugin that, or maybe it's Gronk. Yeah, it's probably Gronk. Grok is a powerful Logstash plugin that enables you to parse unstructured log data into something structured and searchable. It's commonly used for any log format written for humans to read rather than for computer consumption. It works by combining text patterns with the syntax semantic pattern. However, sometimes Logstash lacks the built-in pattern that we need. In these cases, we can define custom patterns using oniguruma syntax and take advantage of regular expressions. More info on Grok is available on their Elastic documentation here, which is the Grok filter plugin, blah, 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 blah. We might need to refer to this, so I'm going to leave that open. We can use the pattern we previously created to successfully extract IPv4 addresses from our log file and process them into a custom field before they are sent to a SIM. In an Elastic Stack scenario, we can add a filter using Grok within our Logstash configuration to achieve this. So this is the input, I guess, and this would be the filter. And it says filter. This seems like kind of like a JSON type of a syntax. So filter, squiggly bracket, grok, squiggly bracket, match that the message equals IPv4 address, and then you give it the specific regex pattern right here, and then close, 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 and then you have the output. So we use our previously defined regular expression pattern to extract IPv4 addresses from the message field of the incoming log. The extracted values will be added under the custom IPv4 address. Typically, IP addresses are extracted automatically by default configurations, but this example shows the power of regular expression patterns when dealing with complex log files and custom fields. The Logstash room and the official grok documentation are fantastic resources for further exploring Logstash. And Logstash room, I'm assuming, is something inside of TryHackMe, which it is, and I definitely have not done this before, so that's going to be something that we'll look at later. So now so alright, so it says, how would you modify the original grep pattern above to match blog posts with an ID between 22 to 26? So it's this specific pattern right here, which is at the very, very top. Where is it? So we got post number right here. So 22 to 26. And we need to modify this thing right here. So how would you do this? So it would be 2, and then it would be 2 to 6 right here. So I would take this whole thing. I don't know if I need the quotes over there. We'll see if we need it. I'll take this whole thing, and then I'll do 2 to 6, and then this will be a 2. So it's going to go from 22 to 26. Yeah, nice. All right, so what is the name of the filter plugin used in Logstash to parse unstructured data? And that is grok. Okay, I mean, they didn't ask us to create a bunch of regular expressions, although I feel like that's going to be really useful. So I'm not going to spend time in this video to do it, but I really do recommend that we learn it together. You know what I mean? I'm going to try to learn it, you're going to try to learn it, and I really think it's going to be super useful, especially when you're going through these types of things. 'Cause this is just, I mean, that was, yeah, I think it's super useful. That's all I'm going to say about that. It's going to be very, very useful. So all right, now let's look at CyberChef, which we've used multiple times already. I already have it open in a tab even. So CyberChef is super freaking powerful. I love this freaking tool. It makes life so much easier, and you can dump a bunch of stuff in here. Base 64 coding, which is, it looks like gibberish to me, but it'll just decode base 64 for you. So let's talk about CyberChef. Super excited. Alright, so CyberChef is a very powerful tool in the toolkit. It is amazing. It's known as the Cyber Swiss Army knife, and it does a bunch of things. So it has over 300 operations, and it can encode and decode data, encryption and hashing algorithms, data analysis like parsing log files and extracting data, and just a bunch of other stuff. So we are going to, I mean, I already have it open in my browser, so I'm not going to do it inside of the attack box browser. If you're a free user on the attack box, a local copy is installed and can be accessed using the offline CyberChef on Firefox. So, I mean, I already have it in my browser, so that part of it is not a big deal. So the operations tab allows you to select what you want to do with the input. The recipe is the overall thing right here, which you can just dump a few of these operations in here if you wanted to. Input is what you want to be processed, and then output is what the output is going to be, where the result is going to be. The demonstration right here is that you take from base 64. So if you want to take something from base 64 encoding, you dump it in here, and then it sends out the output in plain text, which is in this situation TryHackMe, right? So this is the base 64 encoding, which literally looks like gibberish, and then you have the output, which is TryHackMe, right? So very, very awesome and powerful tool that can do that. So if you want to now encode it, right, so you can literally do or actually, I'm sorry, this is super useful. So if you don't know what encoding the input is, you can just use the magic operation, and it takes its best guess, right? So if you don't know if it's base 64 in this case, right? You literally just do the magic operation and you drop it, and it'll just do kind of like, oh, this is what I think it is, and it'll give you an output, which, I mean, it's so freaking useful. I can't explain how useful this shit is, right? So regex with CyberChef. Look at this. This is amazing. So regular expression recipe can be done right here, and you can punch in, I guess I think you would have to type in the reg expression. So we're using this pattern right here, which was for the IP address, to search for values that are IP addresses, right? So you do a user refined regex, and then you type in your regex. I think it can probably even, so let me actually just go here instead of talking smack or whatever. Can I get rid of it? Yeah, I can. So I'm going to go here. I'm going to do regular expression. There we go. And we're going to drop it here. And it says user defined IPv4. Oh, there you go. So if I just do this, it gives me the regular expression for IPv4 addresses. Look at that. If I do IPv6, it'll do a regular expression for IPv6. Very cool. Email address. This is the regular expression for, so look at that. That looks insane. The regular expression for pulling an email address. The regular expression for pulling a domain. MAC address. Very, very freaking cool. And so you could also just do a user-defined regex pattern. So in this particular case, we can just take this thing, which would be our version of the IP address search, and then we would paste in whatever the data is, and then from there it would give us all of the IP addresses from that data. And right here it says, let me zoom in here a little bit. It says the output format, so you could have a list, you could have a highlight, or you could have captured groups, so on and so forth. So in this particular case, it was a list. So instead of just giving you the same output, or it'll give you all the same data, just highlights the stuff, it actually just gave you a list of the information, which I think is probably more useful anyway. So this is it. And then uploading files into CyberChef. Oh my god, that is so freaking useful. So this is why they probably told us to do it inside of the browser here. I see. So we're going to go through this. We're going to extract the file that's inside of task 8. Then we're going to upload the file into CyberChef, and then use it to list all the IP addresses, and then use the same log file to request that's encoded in base 64. So what's the decoded value of that? And then using CyberChef, decode the file name, encoded flag, and use the regex extract MAC address. What is the extracted value? Okay, so first and foremost, as we know, we're going to go back one. We are going to go into task 8, right? So cd, no, I got to go back one more, and then now I'm going to go into task 8, and then ls, we're going to unzip the log analysis zip file, and that'll happen. And then we're going to go into cd log analysis. Oh, interesting. So instead of I see. So it didn't give me another directory. It just gave me the files. So there it is. So you have access log and you have the encoded flag. All right. So now I know that I have this, and I am going to open up my browser, and then I'm going to go into CyberChef, because they said that it's already included here, and it's an offline version. So we just got to wait for that to load real quick, and click on the little thing. It says offline CyberChef right here. So we're going to click on that. It'll take us to the offline version of CyberChef that's on our local machine here. I'm just going to open this up to make it a little bit easier for us to navigate. And we'll maximize this window. And so the input is going to be for us to add a file. So open file as input. Here we go. And I need to go into desktop, and it's going to be inside of tools, and it's going to be inside of, no, not tools, I'm sorry, it's going to be inside of rooms. There we go. Inside of rooms, and then we're going to do intro to log analysis, task 8, and then we're going to take our access log as our first log. And there we go. And we got a bunch of stuff right here. So let me kind of do this a little bit so we can make some movements, some easy movements. There we go. This is the recipe. Bring this here. Okay, so the first thing that we want to find is use regex to list all the IP addresses. What is the full IP address beginning in 212? So first I'm going to look for regular expressions, and there we go. We're going to paste that here. And it already has the thing for IPv4. So I'm just going to do IPv4. And instead of highlight, I want to do list all the matches. And there we go. So we got all of the IP addresses right here. So what we want to do is we want to find the one that is 212. So it starts with 212. And there it is. So I can only imagine that this is the only one. I hope this is the only one. So there we go. We copied that, and we're going to go back here, and we're going to paste this here, and that's it. All right, cool. So we got that. Then we got the next one where it says use the same file, and a request was made that was encoded in base 64. What is the decoded value? So inside of this thing, there's a request that was made that was in base 64. So I'm going to go here, and I'm going to do base 64. So from base 60, I'll just do base 64 like that. So from base 64, right, from base 64, and I want you to give me something, and it's giving me a bunch of jargon here because a lot of these things aren't even legible, and I need to find the request that was made. Okay, so here is what I was able to find. So first and foremost, I figured that if we just used, so I'm going to turn this off real quick, if we just use the base 64 thing, which you will see real quick, I mean you already saw, so I'm just going to just show it to you again, but if we just use that, I deactivated this thing. If we only use this thing, you see that everything over here is jargon, like it's gibberish, you don't notice what's going on. So if I turn this off and turn on the regular expressions filter that I found, and I literally went to Gemini and I was like, hey, I want you to just help me create this thing. I'm looking for some kind of a request, so either a GET request or a POST request is what I'm trying to filter for, and I want you to try to help me find basically all of the GET and POST requests. And I did exactly that, and then now it gives me all of these GET and POST requests, right? So if we go through these requests right here, we actually get to see something that's very interesting. So there is something right here that, you know, just based on my eyes, because I'm a little bit trained to look at these things, this piece right here looks very much like a base 64 piece of code, right? It's mostly gibberish compared to all the other lines that's going on here. It's the one that is closest to base 64 in my eyes, right? So this is a query. This could potentially be it, but I don't think it is because it has the PHP thing at the end of it. And so for me, in my mind, I think that's the one that is going to be our winner. So what I'm going to do is I'm going to do this, and I'm going to paste that in here. And now what we're going to do is we're going to turn on the base 64, and we're going to turn this thing off. And voila, there we go. We got it. So this is the flag that we wanted to collect here. And now I can take this, copy this, and go into our tab here and paste it. And that should be, where am I? It's right here. So now we're going to go paste this here, and that should be our flag. Excellent. Okay, great. So now finally, we can go and decode the file named encoded flag and use the regex to extract by MAC address, which should be fairly simple to do. So I'm going to go here and add another file, which is our encoded flag, and then we're going to turn the base 64 off. We're going to go back to regular expressions and turn it back on, and then we're going to do MAC address, which is this thing right here, and then we want to bake it. So bake it for MAC address. Okay, so the way that this one worked was instead of having base 64 be the bottom recipe, we had to put base 64 at the top because this is all base 64 encoded, and it's supposedly, I think it's just a list of MAC addresses, supposedly, I'm not exactly sure, but if you have base 64 as your top recipe, and then after it does decoding from base 64, and then you put the regular expression recipe here that has MAC address in it, it'll now give us this MAC address. So we now have that, and we can go here, and we can go here, and we can paste this here, and boom. Okay, cool, we got it. All right, so finally we have log analysis tools known as Yara and Yara rules and Sigma. So let's check these out and we will be done with this room. All right, Sigma is a open source tool that describes log events in structured format. It can be used to find entries in log files using pattern matching. It's used to detect events, create SIM searches, identify threats, and it uses YAML syntax. What we're going to do in this task is demonstrate being used to detect failed logins in SSH. So writing a Sigma rule is out of scope for this, so we're not going to actually break it down. But basically, this is what it looks like, right? So you have the title for the rule, the description of what it does, the status, the author, and the log source is going to be Linux and SSHD. And the detection, this is kind of, I believe this is the pretty much the full portion of the rule right here. So it's going to go through the selections, find this. This is speculating at this point. So the title is the value. This is the outline purpose of the Sigma rule. This provides the description of what it does. This is the this key explains the status of the rule. For example, experimental means that it needs further testing. This is the person who wrote it. Where the log files that contain the data that we're looking for are going to be found, which is the log source. And SSHD is the detection. So the key lists what Sigma rule is looking to find. And A0 contains failed. In this case, it looks for all entries that have failed. And then A1 contains illegal. It looks for all entries with illegal. So it has both of these search parameters in here. And under false positives, users forgetting mistyping their credentials, this lists where this entry may be present but doesn't necessarily indicate malicious behavior. This can be now used in SIM platforms to identify events in the process logs. If you want to learn more about Sigma, you got to go look at the Sigma room, which I got to do. I haven't done. Yara, I've done a video. I think I've done 2 videos on Yara rules. So I'm a little bit more familiar with this. And this is another pattern matching tool, and it's YAML formatted, and it identifies information based on binary and textual patterns like hexadecimal and strings. It's mostly used in malware analysis. That's actually what we did the videos on. But it's very good for log analysis, and this example finds the IP finder. So this is called the rule, which is the IP finder, and it uses regular expressions to search for any IPv4 addresses. And if the log file that we're analyzing contains it, Yara is going to flag it. So this is the rule, which is the IP finder, and you do a squiggly bracket, the meta, which is just the meta description and the meta tags and stuff like that. The strings is what it's going to be looking for, and the condition itself is IP. So the rule itself, that's the name of it. The meta is just the metadata, and then the string itself, this key contains the values that Yara should look for. In this case, it's looking for the regular expression for IPv4, and if the variable IP is detected, so that's the condition, right? So this is the string, and this is the condition that's going to raise this rule. So if the variable IP is detected, then the rule should be triggered. And if you actually go and want to use it, you would end up doing this inside of your command line. So you're going to say, Yara, I want you to use this specific Yara file against this text file, and then it's going to give you your results. So it can look for multiple IP addresses based on a range, IP addresses in hexadecimal. If an IP address lists more than a certain amount, any combined with other rules, for example, if an IP address visits a specific page, and there's a lot more on this. And I pretty sure have done the Yara room. Yeah, I have done this. So there is definitely a video on Yara, I think at least one, but for sure, or I know for sure that there is one, but I think there is 2 videos that you can go check out. So Sigma uses YAML. What keyword is used to denote the title of a Sigma rule right here? In this particular case is going to be what title? So this title outlines the so key, or I'm gonna say title. I don't understand why it would be anything else. Yeah, title. That was weird. What keyword is used to denote the name of the rule in Yara? And it's going to be rule. So rule is the keyword for that. And there we go. That one was easy and straightforward. But these are useful. I mean, we're getting into the weeds of of these rules, and I think it's very, very important for us to learn how to decipher log files or parse through log files, and all of these things are just super useful. Honestly, I've never used CyberChef to break down regular expressions and things like that, and that part of it was extremely useful to me. So I'm very, very excited about kind of looking at CyberChef in a new way, and this was just very, very helpful to me. So as it says right here, we need to go into Advanced Splunk and Advanced Elk, which is the very next series of modules that we're going to be doing. So we are officially done with our log analysis module, and I'm super excited about it. So we got some good content out of this thing, and the very next series inside of our SOC Level 2 pathway is going to be the Advanced Splunk stuff. So excited for it. I hope you guys got a lot of value out of this one. Alright, if you got value out of this video, or if you've gotten value out of this channel in any capacity, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And I welcome you to go ahead and drop a comment. Oh, there's a new comment that came in literally 57 seconds ago. Bro is cooking in his channel, and I just found out about it. I'm so excited about these freaking comments that come in. It lights up my energy. You have no idea. But the comment section is super lit, man. I'm telling you, there's a lot of good stuff that comes through here, and there's a lot of questions that come through here that I give really long answers to. So this is not something that I take lightly, you know what I mean? This was actually one that came recently. So he goes, you know, can you tell me if I apply for a job after completing this, what will happen? And I gave him a full answer right here. So I gave him like a detailed answer, and I do that for everybody. If you ask a good question, I'll make a video out of it, but if nothing else, I'll drop like a really decent response to your comment to just make sure that you get as much value as possible, because I really genuinely appreciate this community and I love everybody that comes through here. And as you know, as an extension of that, I would very much love it if you actually joined us in this community as well. So it would be very cool to have you. And I mean, just to kind of make this a little bit more fun, when we get to 100,000 subscribers, I'm going to reveal my actual identity, or at the very least, I'm going to show my face. How about that? Well, when we get to that point, I'll show my face so you guys can see who I am. And then if you can, you know, if you can find out who I actually am, that'll be cool. But we'll kind of do like a reveal of who Hank Hackerson is, and it should be fun. It should be a cool journey as we go along here. So make sure you like, subscribe, turn on that notification bell, and drop a comment. It's your boy Hank Hackerson at Hank Hacks Hackers. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I hope you enjoyed this video, and I hope you got a lot of value out of it. And I will see you in the very next one. All right, later.